So we have already learned about the atomic scattering factor. Now, uh, the in the second part, just I want to give you some basic idea about geometrical structure factor. Now, atomic scattering factor is the scattering by an atom that is situated at the lattice point, but in case of geometrical scattering factor, you want to calculate the responsibility of the whole crystal or whole unit cell in the scattering of an X-ray. Now assume you have got a crystal and you have given exposed the crystal under some X radiation. Now the intensity of X-ray basically that are scattered or diffracted by the crystal is not only depend upon this F, which is atomic scattering factor, but also some other factors. So some various factors are responsible for this intensity scattered by a crystal that are exposed under X-ray. Okay, so one of the main responsibility parties, that is content of unit cell. This is the responsible form. So if content of the unit cell is responsible, then I have to calculate that how this unit cell or how the lattice point in the unit cell is contributing in the intensity pattern, right? So the X-ray scattered different atoms of the unit cell may or may not be in phase. So first is content, and the second is the phase relationship among the different scattered radiation that are coming from different atom in a crystal. Okay. So you have already learned that the total scattering factor, atomic scattering factor, is basically the amplitude of scattered radiation by an atom and the amplitude scattered by a single classical electron, right? So now if this is so total scattering factor, I want to write this as F H prime K prime L prime, and this should be obviously sum over jth atom Fj e to the power I phi j, right? So the atomic scattering factor of jth atom times only this phase factor e to the power I phi j and sum over this j. Now I can write this as sum over j fj e to the power I. This phi j is basically k into s dot r. You have already learned this. So this k into s dot r, I can write it as twice pi divided by lambda rj dot just s. So s is the normal on the plane, okay, where this fj is the atomic scattering factor and rj is basically the position of jth atom, right? Now this summation extend over the all atom. This summation extend over all atoms that are present in the unit cell, right? So if you extend this, what you will get? You will get that, now assume that there exists a point which is represented by uj, vj and wj. This represent the coordinate of jth atom. Okay, so this is the coordinate of jth atom. Now if this is the coordinate of jth atom, then the position vector of this jth atom can be written as rj equal to uj in terms of basis vector vj b plus wj c. This abc are basically lattice parameter. These three non-coplanar vector. So in terms of ABC, I can write this. Now as you see here, this S represent normal on the surface. So if you multiply Rj dot S, what you will get? You will get just lambda times Uj H plus Vj K plus Wj times L. As if you choose any H prime, K prime, L prime plane. Okay, so S is basically the perpendicular on this H prime, K prime, L prime plane, and this Rj is basically any arbitrary position vector of the J atom. Okay, now if you put the whole thing in the previous form of F, what you will get? This F H prime, K prime, L prime, this will be just sum over J F J e to the power I twice pi times Uj H prime plus Vj K prime plus Wj L prime, right? So now if this Fj is same for all atom, because it's a crystal, so it may be same for all atom, then I can just replace this Fj by F, and what you will get? Just sum of F into S, where this S represent the whole term here, this exponential term. Okay, so S is basically e to the power I twice pi Uj H prime plus Vj K prime plus Wj L prime. Now if you look at this picture, this FHK is the geometrical structure factor. Now as this FHK geometrical structure factor, then intensity from any crystal which I get, that is basically F star F. So the complex conjugate of F into F. So this is mod F square. Now if you look at the X-ray spectra which is coming from any crystal, that is basically depend on this structure factor F, because intensity depends on that. Now the structure factor basically depends on this factor. So for a given crystal, I may not get all types of radiation which are scattered by all types of plane in the crystal, because the combination of HKL for which this scattering this S have becomes gives me the value, then I will get the structure factor. But if this S becomes 0 for any particular combination of HKL, then I I am getting this intensity 0. So if for any given HKL, if I write that S equals to 0, then F equals to 0, intensity 0. And for a given HKL, S not equal to 0, then the structure factor have some value F prime and intensity equal to F prime star F prime. Okay. Now let us use some example that when I will get structure factor or not. For a simple cubic system, there will be no problem, because we with this FH scale I will get for all types of refraction. So the refraction pattern produce large values, large peaks for all types of reflection. But if you choose a body centered cubic system, what is body centered cubic? A cubic system, okay, there exist all corner contains some atom, and there exists another atom at the center of this cube. Okay, so looking at this picture, if you choose any coordinate system here, so this point is basically 0 0 0, and this point I can choose as half half half. So the general position of this particular cubic system, B.Sc cubic system, has 0 0 0 or half half half. Why I'm not taking this? Because this atom may be the origin of the next cell, or this atom may be the origin of the next cell. So for the sake of for the for the computation of this structure factor, I am only using these two atoms at 0 0 0 and half of half. Now if you put FH scale, what is the value of FH scale? Here this should be F, because all atoms are same. Now sum over e to the power I twice pi UH plus VK plus WL. Now UVW, this should be 0 0 0 and half half half. Okay, now if you put this 0 0 0, this becomes 1. So FHKL, this becomes 1 plus F times 1 plus e to the power I 2 pi. Again this becomes half of H plus half of K plus half of L. So this becomes F's 1 plus e to the power I pi H plus K plus L. Now look at this figure. So what you will see, that if H plus K plus L equal to odd, okay, if H plus K plus L equal to odd, then F equals to 1, F1 minus 1, because if this is odd, this gives me minus 1, so F becomes 0. Okay, so for those lines, for those planes, or for those reflection for which H plus K plus L becomes odd, this structure factor becomes 0 because intensity is maximum. Then those are called absent lines. Those are the absent lines for this specific type of plane. So for BCC, the planes, the reflection like 1 0 0, 1 1 1, if I assume 2 1 0, okay, these diffraction lines are basically missing. But for which this h plus k plus l, this becomes even, those lines are present. Okay, so h plus k plus l odd is absent, and h plus k plus l even, they are present. So h plus k plus even means those lines are 1 1 0, 2 0 0, 2 2 0, same as 1 0 0. So this should be 2 2 2, etc. Those lines are present for BCC crystal. Okay, now if you choose an FCC, that is face-centered cubic system. So what is face-centered cubic? Here exists a cubic system. Now each corner contains some atoms, and each face contains some atoms. So if you choose this point as center, so the general vector will be this, this, and this. Okay, these three vectors will be general for a face-centered cubic system. Now this origin is 0 0 0. This should be either half half 0. This may be 0 half half, or this may be half 0 half. Okay, and rest of the part I can generate from this general system. So the general points of this vector is basically this 0 0 0, half 0 0. Now if you sum over all the structure factor, that is FHK, what you will get? You will get just, this should be sum of f to the power I twice pi u h plus vk plus wl. So you just put in place of u vw just 0 0 0, half of 0, and this, all this term. So what you will get? 1 plus e to the power I pi h plus k plus e to the power I plus pi k plus l plus e to the power I pi h plus n. So you will get all these terms. Now if you look at this thing, you will see that this structure factor is only non-zero when either h, k, l all are even or all are odd. Okay, and for that case, basically the structure factor becomes 4f, right? So all are even, all are odd means 1 1 1, 2 0 0, 2 2 0. This reflection are present, But the mixed reflection, that is 2, 1, 0 or 1, 0, 0 or 1, 1, 0 or 2, 1, 1, those are absent, right? So this is basically the complete picture of structure factor. Now hope you will understand everything. So thank you.